Good morning, year 11. No, sorry. Year 10s. I forget that you guys are year 10. You guys are so good. It's hard. I get them confused sometimes. Hey, everybody. It's nice to see you. Kieran, I have now sent you the retest. Yeah, sorry it was a little bit late. I obviously I did have it in my head. The register's going really well. Nick and Wen have just showed up. I like it. Nick. Ashley is still not here. Does anyone know where? I'm missing Con. I'm missing Ruby. Does anyone know if Yora's here in the house? Oh, thanks, Wen. You're such a star. I'm missing Ashley, Harris, Ruby, and Con. Ah, there's Con. Now, I'm looking at the register. I know that Ruby's been absent for... Ashley was late to her last one. And Harris was absent for the previous one. So I think what I'm going to do is I'm just going to get started. Can I just say, guys, it's really nice to see that, some people have already submitted their retest. It's really nice. Toby smashed it with 15 out of 20. Well done. Wen, 16 out of 20. Big improvement. Well done. Really pleased with that. That's great. It's so nice to see people making improvements like that. They're really good. It's a solid result, that 75%. Obviously, continuing to focus on the harder level questions. If you want to see the, I'm suddenly realizing there are people who haven't done it yet. I have been through the answers with my year 11s on a webinar, so if you want to see them, you can. If you've done it and submitted it, then go through it. It's worthwhile. If you go to my YouTube channel, it's on there. I think as I can't remember. A-level calculation start. I went through it the other day, so it is there. See if you can track it down. Okay. Right, last lesson. I'm gonna gasp. I don't know why Rooming's gasping. Gasping for air. I'm gonna mark Harris, Ashley, and Ruby as absent, and I'll then mark them in later if and when they show up. I like it. Let's get rid of that. Okay. Let's crack on. Crack on, ja. Let's crack on, ja. Right, share screen. Boom, 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 boom. We are continuing with acid-base theory. Yeah, let's get rid of my face altogether. No one wants to be looking at that. Right. Okie dokie. Okie dokie. Right, on that one. So, guys, this is what we were doing yesterday, which is awesome. I had a lovely lesson yesterday. You guys are great. Obviously, you guys accused me of lying to you in everything. It's not true. Acid base is a particularly difficult topic to teach at Key Stage 3 and GCSE because we do have to make some alterations. But most of the other topics, guys, I've taught you at almost A-level. So, I'm not lying to you. If anything, I'm giving you more than I should. Yeah, have that. Okay. So the learning objectives that we covered last lesson, we recalled the acid and base stuff from Key Stage 3. We went through, oh, Harris has just shown up. Thanks, Harris. We went through Key Stage 3 acids and bases. One of the things that I do realize that I've missed are indicators from Key Stage 3. We need to go back and have another quick look at Key Stage 3 indicators. We went through all of our important acids and bases and we highlighted them, which was awesome. And we didn't manage to get onto the dissociation. But what we did do at the end, and I kind of threw it in right at the end, I was talking about this idea of proton donors and proton acceptors. And I even gave you guys the ionic equation of neutralization, which I think is awesome, which is the bottom one, the very last thing I gave you. This amazing equation, which, by the way, in my eyes is beautiful. Oh, Ashley's just turned up. Hey, Ashley. Oh, you guys are funny. There we go. All in the house. Just Ruby's absent. She can always watch it back later. Okay, so yeah, and I just want to probably add this extra name to this. This was all a bit rushed, and I feel a bit bad about that. This equation here, which you can actually highlight for me. Yeah, that one there. And it is very important. EdXL love this. Yeah, they really do. This is called... oh, pen's super thin. Gonna have to make that a bit thicker. Hang on a minute. Let's go mad. Yeah, there we go. This is called the ionic equation the ionic equation for neutralization. And I actually use this equation when I step into A-level. I use this equation quite a lot because you start picking up this concept of ionic equations. You start, this is a concept which isn't really heavily explored at GCSE. It just isn't. You do a little bit of it, you do a little bit from electrolysis, and you see it here. Those are the only two ionic equations that you get at GCSE. Yeah, ionic equations include, neutralization, which does come up, they do like it. Neutralization, and electrolysis is where we tend to see ionic equations. Yeah, but most students really struggle with the concept. And just to explain what an ionic equation is, an ionic equation is showing the particles that are actually doing something. And I'm tempted just to give you a tiny snippet of an A-level lesson. And it kind of feeds into my lesson today. I'm actually realizing how far zoomed out I am. So I'm going to zoom in so I can get more on the page. So just to show you what I mean by an ionic equation, if we have, I've suddenly realized I made it too full. If I have an acid and a base, we can now, I've suddenly realized, what I'll do is I'm going to come back to this after dissociation, after my learning objective. So, okay, so today's lesson, which is acid-base lesson 2. Yeah, so let's zoom in. So we've got acid, whoa, blimey. There we go. Acid, base, GCSE lesson 2. Yeah, my learning objectives, you can get these on your book. I saw that Shan was like, I've already got 5 pages left in my beautiful book. Shan, you have absolutely smashed through your exercise books. We are clearly writing way too many words. I need to write down less. Yeah, I remember when I was in school and I hated writing stuff. So I always tried to be one of those teachers who tries to do as little as possible. Yeah, because that's why I write all my own notes. No copying down of PowerPoints. I do everything to make it as compact and as useful as possible. Same, Tong is also really close to the end of her book. Oh no! Well, hopefully we'll be back in school soon and you'll be able to get another one. I hope so. So understand this, right? And now I've written the learning objectives on my YouTube channel, but I am actually going to add an extra word here. The word dissociation of acids, and I prefer this word. It makes more sense to me. However, I do need to put underneath it another one, ionization. I actually don't really like it very much, but those two words, technically dissociation and ionization, in this context are interchangeable. I'm using another book, ADY. I don't know what's ADDY. I'm on the first book still, though. How? You're just writing smaller words, Ashley, that's all. Being a bit more compact. I love that. Tong's got 5 pages left and she's already on the second book. Holy moly, Tong, you're going to have, you and Shan are going to have beautiful notes. You guys, I definitely need to make sure I know that Shan's already posted a copy of most of her notes on the classroom, which is amazing. The second learning objective is be able to define weak and strong acid base. I'm just going to put AB. You know what it means. Yeah. And the last one is know the Bronsted, Johannes Bronsted and Thomas Lowry. My other class helped me out with that one. I didn't know the first names since the other day. Bronsted and Lowry, A-B definitions. Yeah, I think we actually covered them technically last lesson, so that'll be a nice bit of revision there. Okay. So today we're going to be talking about, first of all, I want to start off with dissociation. So the word dissociate, all on the chat, please. Can everybody please tell me what they think the word dissociate means to you? Just who's going to be first on the chat for dissociate? This is a bullet point. Dissociate. What's it mean? The opposite of associate. Separate. I like it. Rooming. I like that. As long as you know what associate means, I don't mind. That's great. The opposite of associate. Yes. To separate, Shan, is perfect. Kieran, difference. No. Shanley, Lmaorm. Oh, rooming, laughing out of rooming. Rooming's is better than yours, actually, Shan. Sorry about that. But I do understand that if you don't know what the word associate means, then yours is better. Yeah, I do understand that. It does mean to separate. It means to come apart. Yeah, dissociate. I'm going to use Shan's word, to separate. To separate, bracket / split. Yeah, dissociate. So when you have an associate, yeah, that's someone that you have conversation with, is someone who you are friends with. But if you dissociate yourself from someone, you're going to cut them off. Yeah, so dissociate tends to be used in the context of people and friendships. Yeah, they tend to say, oh, you know, if you're associated with these people, they're your friends. Yeah, social. It comes from the word social. But the word dissociate means to separate, split, no longer be friends with. Yeah. Now, like I said earlier, in acid-base context, got to be super careful with this word. I don't really like it because of it. In acid-base context, ionization is the same thing. Yeah. Now, there are some values to both of these words. Yeah. I don't like the word ionization because there are issues with how it relates to other things outside of this context. But there are values to both. So let's now look at what this means for an acid and a base to dissociate. So we know, so we can do acid, subtitle, acid dissociation. Dissociation. There we go. Right, number one, fact number one. It occurs, it happens when acids or bases, acids, are put into water. Yeah. So did the dissociation, the splitting of acids, that's, I'm going to just start using that word really. Yeah. The splitting of an acid. So acid splitting. Yeah, it's quite nice to do that. You're not allowed to actually call that in your exam though, just so you know. Acid splitting occurs when acids are put into water. So what do we mean by splitting? And where does the word ionization then tag on? Yeah, so let's have a look at an acid. Let's go for our favorite acid, HCl. Yeah, we love HCl. On the chat, please. Number one, by the way, it is a gas. So number one on the chat, please. What kind of bonding is HCl, please? By the way, I am going to start bullying people on the chat soon. I'm going to start picking on people because the same people tend to contribute on the chat, and it'd be nice to see a bit more variation. So I'll start picking on people. Yeah. Nick, covalent, smashed it. He's on this. Kieran, well done. Ben, Ben. Simple. I love the fact that Kieran did covalent and followed up with simple. I like that, Kieran. You don't need the word simple, but I like to actually include it at GCSE. Ben, non-metal. It's covalent. Come on, Ben. Let's turn that now. Let's draw all the pictures that I know. Ashley. Ben, you're getting slated here. You need to come on, Ben. You're better than this dude. Yeah, mistake. Love it. So let's turn this into all our pictures. Wait, why don't we need to include simple? Okay, Kieran. So, okay, just a reminder of bonding. In bonding, there are 4 types. Yeah, we have covalent, we have giant covalent, giant cove, we've got ionic, and then we have metallic. Well, I always like to include the word simple, yeah, because it helps make the distinction between giant and covalent. But because the giant covalents are rare, there's only, I mean, like, you guys only have to know about 6 of them for GCSE. Diamond, silicon, silicon dioxide, titanium dioxide, graphite, graphene, all the graphite derivatives, but that's it. They're rare. What that means is, if someone says, oh, covalent bonding, we assume simple, Kieran. Yeah, it's way too early, I'm sorry. Oh, Ben, it's okay. It's too early for me too. So you don't technically need the word simple, but they won't penalize you for it. Amazingly, they don't even penalize you for it at A-level either, even though I really dislike it when they get to A-level. I'm like, guys, if you say covalent, you're meaning simple. Yeah, but it's because the giants are so rare, everything else is going to be simple. Yeah, if you look at anything around you, the chances of coming across a giant are very slim. Yeah, I mean, well, in fact, most things, everything else is giant. Ionic's giant. It is actually giant ionic, and it is actually giant metallic. Yeah, but we don't tend to call them that because we then assume that they're all giants, because they all are. All ionics are giants, all metallics are giants. So we don't ever tend to use it, but we have to use it when we run Susan Boyle's things, Nelly the Elephant. We have to remember to say giant ionic lattice, giant metallic lattice, all that jazz. Anyway, so let's convert this into all of our pictures. So the next thing is the dot and the cross. Yeah, we go from this here is the molecular formulae. Yeah, and then we can go to the dot and cross diagram. Dot, cross diagram. Everyone in the room will remember this. Yeah, we now have to show them that they're overlapping. In the gap goes a dot and a cross. Don't do them horizontally. I keep seeing students do that, and I don't know where you're getting it from, but don't. Yeah, try to do them horizontal in the gap, although they probably wouldn't penalize you. I still don't like it. Yeah, there we go. So there's the dot and cross diagram for HCl. Hydrogen, of course, only having 2 electrons in its outer shell, chlorine now having 8. And then we can also change it to the stick diagram, otherwise known as a displayed formulae. Yeah, so like that. Yeah, this, it shouldn't call it a stick diagram. I should call it the displayed diagram. My pen's not rubbing anything else anymore. There we go. This is the displayed diagram. It shows all the bonds. Displayed diagram. Displayed formulae. Yeah, displayed formulae. So we're showing all the bonds. And it's nice to just do a bit of reminder there of the GCSE bonding bit. So here's now the cool bit. We discovered very early on. Now, the person who first suggested this, the history of acid bases. It was Arrhenius. So there was a very famous scientist. He actually lost his job at the university because of this theory, and it was then proved to be correct years later. I think actually after he died, posthumously, which is a bit sad, really. But what we discovered, and this was actually and it's nice to mention a bit of the history because I always feel like scientists often get forgotten. So the scientist here was called Arrhenius. I can't spell Arrhenius. I think it's a double R. Arrhenius, I think. That someone can check me. And Arrhenius was the very first person to say, when acids and bases are put into water, they split up and they form ions. So this is what he now said. He said, and this is the picture I was going to draw earlier. Yeah, this is water. This is water. Shouldn't write the word. Should always do the first. This is just H2O. Yeah. And I add the acid to water. I add HCl to water. And something really amazing happens. The HCl goes through a process called dissociation. And it splits to form these two. So the word dissociation kind of makes sense. Before, these two were said to be associated with each other. Associated. Yeah, because they're bound together. Yeah, they're in a relationship, if you wish. Yeah, and then all of a sudden, they go into water and they separate. And they become ions. Now, this is where, of course, the term ionization comes from. Yeah, in acid base. This is dissociation or ionization in the context of acid base. You can call it either word, they don't care. You use whichever one you prefer, guys. Yeah, the ionization, it has benefits because it reminds you that they're forming ions, but the dissociation is reminding you that they're splitting in half. So this is kind of a neat thing to happen. And What we now realize is, well, doesn't this happen with all ionic stuff? Yes, Kieran, it does, as long as it's soluble. If ionic compounds are soluble, then they will be going through a process of dissociation. We don't call it dissociation, by the way, when it's ionic. We call it dissolving. Yeah, the hydration of the ions. It's dissolving is different from dissociation, because in dissolving there were electrostatic attractions between the ions, but this is the breaking of a covalent bond. Like, this is really special. Yeah, this is unusual. Let's look at another one. Let's look at another acid that we know and love. Everyone loves sulfuric acid. By the way, it's the probably the most dangerous thing I have in my arsenal in terms of acids in school. I don't have HF. I'm not allowed it. Wouldn't want it anyway. Wouldn't want HF. Nasty stuff. But let's now turn this into so on the chat, Ben, going to ask you specifically now. Ben, what type of bonding is in sulfuric acid, please? Let's see if he puts it in on the chat. And I can start my diagram for dissociation. Let's see how long it takes Ben to get on the chat. Come on, Ben. Where have you gone? Dissociation / ionization. There he is. Oh, Ben, have you seriously just done it again, Ben? I know it's early. Holy moly, Ben. Holy moles. Ben, all non-metals. Oh, Ben, there's no metals, Ben. Hydrogen is a gas, sulfur is a non-metal. Oh, don't laugh too hard, Ashley. It's too early for him. Are you with me now, Ben? Remember, you only get ionic when it's a metal and a non-metal. Agreed? Okay. Let's now turn this into, let's just do the display. So this is molecular. The actual number of atoms of each element in a compound. Ben, that's correct. Non-metal plus non-metal is covalent. Well done. Spot on. Molecular formulae. Yeah. Let's now turn this into the dot and cross. Oh, people aren't going to like this. Yeah. Sulfur, oxygen, 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 oxygen. Let's put the symbols in. Yeah, and then hydrogen, too big. Hydrogen, hydrogen. It's actually easier to do the sticks in this case. Yeah. Here's the displayed formulae of sulfuric acid first. Yeah, it's rather funky. And then the dot and cross, hydrogen, of course, there. This is easy for the hydrogens because I can put a dot and a cross in the gap and then a dot and a cross in the gap. And then the oxygen, this one has a single bond. Oxygen makes 2 bonds. Yeah, so I just need to remember to include that one up there as well. To get to 8, 2, 4, 6, 8. Seems reasonable. Oh, that doesn't actually make a lot of sense, does it? Oh, that's awkward. Oh, it's because it's a single. I'm an idiot. I'm an idiot. I'm a dope. I'm a dope. There we go. Ah, thank you. 1 bond there. There you go. That's better. Freaked me out there for a minute. Titanium dioxide noises. Huh? I have no idea what that means, Rue. There we go. And then then double bonds down here. There we go. 2 and 2. This does break a GCSE rule. I wonder how many of you guys will spot it. To Ben's comment. Wait, no, never mind. Yeah, I have no idea what you're talking about, Rib. Anyway, so we're going to ignore the dot and cross just because it's a bit messy. Yeah. I mean, that's still a covalent. Okay. Anyway, so I take sulfuric acid. I'm going to add it to the water. Yeah, and what's going to happen? It's going to split up. So what I'm going to do is I'm going to do it before and after here. So it goes into water, and instantaneously. You will never get that case. Nope. It will immediately, spontaneously, split up to form SO4 2 minus, SO4 2 minus, and 2H pluses. Metal, non-metal. Rue, your chat makes no sense. I have no idea what you're talking about. Oh, yes, titanium dioxide does break the rule of it is giant covalent. Yes, you're right, it does. So as soon as it goes into water, this happens. It splits, it ionizes. And what we now need to do is, rather than the picture, let's now see the equations. So these are called dissociation equations. Dissociation equations. Or ionization equations, you could do either. And I have to teach you both because Edexcel will flip between the two words. Yeah. So we had HCl went in as a gas. It was added to water, and it splits to form H plus and Cl minus. And these now are both aqueous. Now, I just want to point out here, folks. I've lost it. I was going to say something, don't know what it was. Lost it. Oh, conservation of electric charge. Yeah, I just want to talk to you guys about the conservation of electric charge. I only started teaching this really, but what I want to quickly show you is this idea of electric charge. We know in chemistry, we come up conservation of mass. Yeah, conservation of mass. And what that means is if you put in 100 grams into a reaction, you will get out 100 grams of product. We know this. Conservation of mass. The reactants went in, yeah, and the products come out, and we get the same mass. Yeah. Well, we also have conservation of electric charge. This actually comes from physics. I started teaching this about 7 years ago. Conservation, because it suddenly became really handy for electrolysis and acid base of electric charge. What that means is if you put in a plus, you will get a plus out. Yeah. If you put in a plus and a minus, the overall charge is 0. I will have an overall charge of 0 out. Yeah. This will be a 0 charge out. You might have different ions and how they're distributed, but the charge is the same. I want to show you that with this equation. With this equation, on this side, there is no overall charge. HCl has no charge associated with it, so it's 0. And on this side, we have a plus and a minus, which gives me an overall of 0 charge. So it's just really handy for balancing equations. Let's look at another one, and this is where this might come in handy for some of you. Yeah, let's look at the dissociation equation. The equation for sulfuric acid. Sulfuric acid goes in like this, and it splits. Now, here's the most common mistake at GCSE. They will write down this. Yeah, but there's a problem here. A H has vanished. Yeah, and some people like to do that. Nope, can't do it, because that would still not add up in terms of charge. That tells you that the two atoms will be joined, which is wrong. They're now separate, and I need 2 of them to balance the charge out. On this side, I have an overall charge of 0, because there's no charge on sulfuric acid. On this side, I have a +2, because I have 2 of them, and I have a -2 as well, which means the overall charge is 0. It helps when we balance equations. It becomes really handy. Anyway, so there's the dissociation equation for sulfuric acid. Okay, so should we do one more? And this one, you guys can put it on the chat. Yeah, nitric acid. What am I going to make when I put nitric acid into water, please? Give me it on the chat, please. Ben, I'm going to come to you again. I want to give you a good chance at getting an answer right then. Come on. What am I going to make when I put nitric acid into water? Add to water. add to water. Yeah, what am I going to get? Come on, Ben. What are the things am I going to, what 2 things am I going to get, Ben? Bam, 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 bam. Dun, dun, diddle, dun, dun. I think Ben's just left the room. He's like, I'm not watching this anymore. I refuse. Searching it up. Nick. Yeah, he may be searching it up. You're right, Nick. Nick, can you give me the answer, please? You shouldn't have to search this up. Oh, well done. No, that's not right, Ben. You've gone a bit crazy. I don't really know what that means, really. Your equation is all a bit... countdown, lol. So what's going to happen is, remember, there's a theme here. Look at the last 2 equations. What did I get in both equations when I put an acid into water? What was the common theme? Thanks, Con. Yeah, we're going to make H+. H+ is what makes an acid an acid. So I'm going to get H+. And the question is, what's left over? It must be NO3 minus. Yeah, there's my equation. And the charge balances. Thanks, Con. Well done. Good job. So it's quite nice to see the equations and to understand what's going on. They're just splitting up into their separate ions, hence the word ionization, but they're splitting, hence the word dissociation. So now that we understand that they split, these are the bits that we're trying to then focus on to realize that H+ is acid. That's what I need all of you guys. I need to burn into your brains that guy. When you see that guy, it should scream acid. Yeah, you should be like, that's what makes an acid an acid. It's what burns you. It takes the electrons from you, which then makes all your atoms become positively charged and then soluble in water. So you dissolve into the water that makes up your body. Gross or what? Big grin there. Suddenly realized how far I went. Apologies. Brilliant. Okay, so now that we understand dissociation of acids, yeah, we can kind of go, all right, let's now look at the bases option. We've done acids, we now need to do bases. So if I put a base into water and it's soluble, that is one of the things it depends on, yeah, and it's soluble, let's now do base dissociation. Base dissociation. I'm going to give you a whole load of questions in a minute, guys, for you guys to do in your book, and then we can mark them together. So base dissociation, sodium hydroxide is a white ionic solid. And I'm going to add it to water. Add to water. What am I going to make, please, when it splits up? Everyone have a go on the chat. As many people post as possible. I'm now not really testing whether or not you can do this, more about whether or not you're still in the room. Trying to make sure that everyone's still watching. I know that people seem to be wandering off. I miss Ruby. Where's Ruby? Oh. Right, come on, guys. What am I going to make? What am I going to make? What am I going to make? Chong's in, Kieran's in, Rue's in, Ben's in, Ashley's in, Con's in. I love it, and everyone's getting its spotlight. I love it. I love it. Good job, Moses. Good job, Shan. Look at that. I've just had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people smashed it out of the park. Thank you so much. I love Rue's little up arrow thing. I think that's very clever. You're absolutely right. I'm going to make Na+ and OH-. Again, conservation of electric charge. On this side, total charge is 0 because there's no overall charge on the sodium hydroxide. On this side, I have +1 and -1, which tally up to make 0. Overall charge is conserved. Love it. Good stuff. I love conservation of electric charge. Okay, guys, let's try the next one for you. Let's try this one. It's going to get a little bit trickier now, folks. Let's go for calcium hydroxide. What's this going to give me? And that's a white solid, dissolves into water, only partially, actually. Guys, what am I going to get? Off you go, do it on the chat. Do it on the chat. I only had 10 people there and 15 people watching. Interesting, intriguing. Who's missing? Listen. Andy didn't. Isabel. There's Wen. Nice. Wen, yours is wrong. Check it. Look at Kieran's. Well done, Tong. Great job. Rooming, well done. Ben, you forgot to balance. You forgot to balance. Ashley, well done. Win, good correction. Well done. Con, well done. Toby, Isabel, are you in the room? Where are you, Isabel? Isabel. The Isabel song, guys. Well done, Anna. Good job. Well done, Nick. Good job. Has Isabel just gone? Is she AFK? Look at me, the boomer, doing that. Thanks, Harris. Good to see you. Harris, check how you've done your charges. Your charges wrong. Nick, well done. That's good. Yeah, well done. Where's Isabel? Isabel's AFK. So we now get CA plus 2. Yeah, but we now get 2 OH minuses. The 2 switches sides. Mr. Duncan, how old are you? Are you classified as a boomer? Yes, Ashley, I am very old. Old. I'm like 63. I'm ancient. Do you guys not know that? I shouldn't say that live on YouTube. I'm not 63, by the way. Look at the conservation of electric charge. Yeah. So we've got a 0 charge on this side. Yeah, and on this side, I've got a +2 from the calcium and 2 1 minuses. That makes sense. Yeah, 2 times 1 minus, which gives me -2. Overall charge is conserved. More lies. 63 equals 36. That's so fun. No way you look 18. Ben, whatever, Ben. Whatever. Although you will get an extra mark on your next test for that. Well done. Boomer if born before 1964 and after 1946. I'm trying to imagine Mr. Duncan as an old, eccentric, mad scientist. Yeah, Ashley, I don't think that's very difficult, considering I set fire to myself so regularly in school. Yeah. With the electrocuted hair. Yeah, oh yeah, that's the way I'm going. No way you're 63 because you would have retired. Another lie. I love you guys. You guys are brilliant. Tong's a genius, by the way. Well done, Tong. Well done. Tong was smart. She did the maths. Genius. Well done, guys. So we needed the 2. That's the trap, of course, isn't it? It's the 2 in front of that one. Young at heart. Victoria, I've got a mental age of about 12. Why do you think I like to blow stuff up so much? Yeah, I'm always setting off rockets, setting fire to people. You know, it's just, if I'm going to do it, you're going to do it. Oh, so your real age is 36. Yes, my real age is 36. I don't like it. I'm late 30s. I'm going to have a midlife crisis soon. Oh, hang on a minute. I did chemistry as a living. Yeah, okay, I already did that. Let's do one more, guys. Let's do one more. Okay. I'm trying to think of ones that are going to be tricky for you. I'm trying to trick you up now. Okay. I'm going to do a bit of a mix. Are you ready, folks? Are you ready? Right. So, questions. I like it. So, I'd like HF, please. What am I going to make? Boom and boom. Go on the chat. Next, I want H3PO4. Go on the chat, please. Go. Next, I want aluminium hydroxide. There you go. Boom and boom. Loving this. Look at that. Tong's in there first. Tong, you are smashing it today. Well done. Yeah, Con, well done. Rue, Kieran, smashed it. Shanley, Ashley, well done. Spot on. Ben, well done. Ben, what type of bonding's in HF, please? Kieran's now on to the next one. I'm loving this. How everyone's then swapping over to the next one. Well done. Good job. Outstanding. I love the 43. I love that Rue even put it in a bracket. Clever. Clever man. I love that when you lost the 4. You lost the 4 when. And then Con's onto the hydroxide. Well done. You guys are kicking ass on this. Sorry, didn't mean to say that. Live on YouTube. Didn't say that. Sorry. Oops. So H plus, well done, and F minus. Tick, well done, guys. Really happy. Next one. This one's this one's tricky because I'm now going to get 3 H pluses and PO4 3 minus. I understand the 43, by the way. Totally allowed. That's great. Well done. Next one, I'm going to get Al3 plus and 3 OH minuses. You guys are all over this. Tick and tick. Winner. Cool. I like that. It's really cool. I like it a lot. Like it a lot. Okay. Right. So we now can say that I can now go back to my learning objectives. And I can go, I now have all of you guys doing the dissociation of acids and bases, and you guys can all do equations. Yay! I like it. Right, now we need to talk about strong and weak. Yeah, I'm just very aware of the time. What time does this lesson finish? I don't know. I just don't know. Oh, I lost my phone. Hello, hang on. Hang on. What time does this lesson finish? Is it 10 on the dot? It finishes at 10 o'clock. Got 15 minutes. I need to crack on. Okay. Look at this. Done great notes so far and great stuff. I like it. Okay. Next one. Strong, new subtitle. Strong, aka Mr. Duncan, versus weak. Who do I choose? Yeah. What did I say, Ben? Oh, funny. Mr. Duncan is strong versus weak Ben. Amazing. Okay, so what's the difference between the two of them? Now, you guys in year 7 got lied to. Sorry. I didn't lie to you, by the way, because I didn't teach you. Yeah, it has nothing to do with pH. Nothing at all to do with pH. Yeah, what we realize is that strong acids, let's do the strong acids you need to know. Strong acids include HCl, HNO3, and H2SO4. And here's the thing. Strong acids, what happens is when they go into water, they fully ionize. They all split up. They fully ionize in water. I'm going to write that down now over here. I'm just writing it down again. It's good to get a bit of practice. And we can say these guys fully dissociate or ionize, whichever one you prefer. Fully dissociate, stroke, ionize. Now, the question is, what do I mean by the word fully? Yeah? What this means is that every single molecule has done it. So I want to show you a picture now of that, if I can. I'm going to quickly show you a picture. Go away. Oh, it's opening loads of weird. It's doing something. My laptop's doing something odd. I don't like it. So acid dissociation. And I want a diagram for this. Saves me having to, I can draw it, by the way. H2S? H2SO? What have I done? Oh, thanks. Thanks, Karen. Anyone paying attention? No. Images. Please, 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 please give me the picture I want. It's not going to give me the picture I want, is it? Of course it's not. This sucks. Lol. It's not giving me the picture I want, guys. Oh, it's there. That's rubbish. I'm going to have to draw it. Okay. Thanks, Kieran, by the way. Have I done something wrong? Yeah, 4, yeah. Okay, so we can put a little thing of fully, I'm going to make my pen thicker. No, I'm not going to zoom in. Fully dissociated. Let's draw the picture. Fully dissociated. HCl. Do you know what? I'm going to draw them with the bonds because it's nice to show the bonds in this case. HCl, 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 and HCl. I have got 6 moles of HCl. I'm going to put that into water. I'm going to put that 6 moles of HCl into water. And what am I going to find at the end of it? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Every single one of them splits up. All dissociate. Instantaneously, every one of them, poof, they fall apart. They love being in water. This is now aqueous HCl, so it's interesting as the equation. There's HCl gas, that's hydrogen chloride, and now I have HCl aqueous, which is now an acid. Yeah, this is hydrogen chloride because it's not in water. Yeah, it's not an acid unless it's in water. Acids cannot be acids unless in water. This is now hydrochloric acid. It's cool, that. Just to really boggle your brains, when we go and grab, we're doing a chemistry experiment, and you guys go and grab hydrochloric acid. Hydrochloric acid. The only thing that you do not have in that bottle is HCl. Oh, you don't. It's not there. What you have is H plus and Cl minus. So hence why we call it hydrochloric acid. It's cool, that. The only thing, so if you have a label that actually says this, technically it's wrong. You wouldn't, by the way, we always label stuff with HCl. We don't ever write it down as H plus and Cl minus. We just don't bother. But it's a funny thing, isn't it? Just to think about. The only thing not in the bottle is HCl. We have H plus and Cl minus. Bit of a mind boggler. I always like that. Okay, so fully dissociated. Yeah. So we now pick up a definition at this point, folks. Yeah, definition of a strong acid. Let's do this in a different color, big pen. Strong acid or base, doesn't make any difference. Fully ionized stroke dissociated. I'm literally flipping between the two of them on purpose. Fully dissociated in water. That's it. That's the definition of strong. So the question now got more lies. We have been lied to. It's another lie. More lies again. Acid and base chemistry, guys, is a bit of a mess until you get to A level and you get the full story. You guys are going to have to take A level just so I can teach you the full story. I want to tell this to all my younger friends and watch them spiral down into a pit of despair and confusion. That's really sad, that, Ashley. I thought you liked me. I thought you liked chemistry. You're so good at it. That's why you bully me. I'm being bullied. Weak acids and bases. Okay, so the definition of weak, we now say that they are partially ionized. Partially dissociated, I'm flipping on purpose. Partially dissociated, ionized in water. I don't know what, I suddenly realized I don't want to write it down there because then it looks like it's going to be part of the next line. Partially dissociated in water. Yeah. So what does that? So strong acids, weak bonds. Yes, Kieran, that is a good way of looking at it. Then shouldn't it be called weak because weak bonds? No. Remember, in acid space, everything is about H plus and OH minus. And in strong means I have lots of H plus because it's fully ionized. Yeah, cries in chemistry. Oh, don't cry, Ashley. I know you understand this. I know you do. I know you, Ashley. So what does weak mean? Right, now we need to talk about our very first weak acid. Can I just point out, we've actually had a lot of them appear in the lesson already. I just haven't told you. Sorry. It's not a lie. I just didn't tell you. It's omission. So, if I put vinegar, this is the good one, guys. This is ethanoic acid. Ethanoic acid. And it's organic. This is an organic acid. And just to let you know, over here, little nota bene, yeah, all organic acids are weak. All organic acids are weak. Yeah, all of them. No exceptions. No exceptions to the rules. White lies. Ethanoic acid is so nice because it's pigeon acid. Ooh, yes, Ashley. Do you remember that? Did I taught you that? Yeah, they're pigeons. Pigeon acid. So true. So I'm going to do 6 ethanoics, just like I did with the HCl. It's only fair. Now, guys, this one's a bit more confusing. Students often ask me, why is it written like that? Why don't you put the carbons together? Why don't you put the hydrogens together? The reason being is because this structure plays an important role. Because the H plus on the end is special. Beware the chemistry lies. How ping? Don't be chiming in a lesson that you don't belong to and spouting chemistry lies. I'm watching you, helping. Right, we're going to add them to water. We're going to add them to water. It's nice to see you helping, by the way. We're going to add them to water, and here's what happens. CH3COO minus. Right, guys, you can see where it's split up and why it's written so differently. Yeah, it's break. Oh, yeah. There's no OH minuses. There's no O minus. So here's now the problem. Guys, what do you notice about some of the ethanoic acids? In fact, most of them. How many of my 6 have split up? How many of my 6 have split up? More intruders soon. That's so funny. Dom's just appearing. Dom's appeared. That's so funny. Oh my God, I'm going to raid your class next, Dom. Voila. Yeah, well done, Vic. Well done. Guys, so why is it only part of there, 1 of 6? Thank you. Now, just to let you know, that in reality, 1 in 50,000, it's actually 60, it's about 1 in 60,000 actually split up, actually dissociate. This is why it's weak. And why he's lying to you guys, just helping. I'm going to have to end this chat just because of this. It's lovely to see you guys. You guys are so funny. Okay, guys, I'm going to leave today's lesson there since we are being invaded. I'm gonna leave it there. Go back to here. You guys are so funny. It's lovely to see you all. Guys, have an amazing weekend. And once again, no homework. Yay. You got homework next time. Sorry. But not this time. Go and have a lovely weekend, guys. No, it's not a cliffhanger. I finished. There you go. Partially dissociated. Partially dissociated. Cool mustache again. Thanks so much. You guys are so mean to me. You're meant to be nice to me. Be nice. It's bullying me. Such bullies. Guys, have a nice weekend. I'll see you guys all soon. I'll see you next lesson. Take care. Bye, guys. You're very welcome.